All right, so the next section is to understand the relationship between scattered plots and tables and determine their patterns. Now, you might ask, what is a scattered plot? A scattered plot is a plot that shows a relationship between your x and y variable. As we go deeper into the topic, we will be drawing the best line of fit that matches our scattered plot. But as of now, scattered plot is something that shows you a relationship between your x and y axis, and just by looking at your scattered plot, you can tell if there is a linear relationship or no. So let's go ahead and look at the scattered plots below. As you can see, the first diagram that I have, where is it? All right, so my pen is not working. Just give me 1 second here. All right, so this is the first scattered plot that you see, and as you can see, the scattered plot is going up, so that means there is a positive linear relationship. And you see that there is a positive linear relationship on this one too, but I see that there is a deviation. Not all the dots are in sync with one another and form a perfect line. Now let's take a look at the next one. As you can see, this is a strong relationship, linear relationship, but the line is going down. That means the slope is negative. What does that mean? As x values increase, the y values decrease. Now let's look at this one. Yeah, the graph is still going down, but there's a lot of deviation. And the next one, it is not a perfect line. It looks like an exponential growth. As you can see, it's just going all the way up straight. And the next one, it is scattered everywhere. I cannot find a pattern on this one. So there is no linear relationship. Now let's go ahead and look at the next question. The scattered plot below shows data relating competitive chess players' rating and their IQs. Which of the following pattern does the scattered plot show? Just by looking at the graph, as you can see, as the IQ levels are increasing, the chess ratings are increasing. As I can see, yes, there is a positive linear relationship, yes, but I do see these two dots that are deviated from the scattered plot. So it is positive, but there's still a deviation. So it's a positive linear pattern with deviations. So if everything is in a perfect sync or perfect same line, then it's a positive. But if you see dots randomly here and there, that means there's a deviation in the scattered plot. All right, now let's go ahead and take a look at the next one here. Annie keeps track of amount of time she practices her three-point shot in basketball each week and the number of three-point shots she scores in the game that week. That's very good. So she's not only keeping score of her three-pointers, but the amount of shots that she scores in that particular week as well. The data are shown in the table below. Which of the scattered plots below accurately record the data? So the best way to look at this is I like to go ahead and look at the coordinate points. As you can see, the coordinate is 1 and 3, right? 2 and 5. That means my x value is 2, my y value is 5. My x value is 3, my y value is 7, x value is 4, y value is 7. So that's the best way to look at the plots here. So let me go ahead and look at the plot. 1 and 3, yes, 1 and 3. 2 and 5, yes, 2 and 5. 3 and 7, no, that's not 3 and 7, that's 3 and 8. So this is not my option. Let's go ahead and look at the next one. I have, let's see, 1 and 3, yes. 2 and 5, yes. 3 and 7, yes. 4 and 8, no, this is not my option. Let's look at the next one. 1 and 3, yes. 2 and 5, yes. 3 and 7, yes. 4 and 7, yes. 5 and 8, yes. So this is my option. So be very careful when you are looking at your x and y coordinates. Those are the ones that should lead you to the right answer. All right, now let's go ahead and look at one problem from your simulations in your homework. Let me go ahead and pull that up. Da, 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 da. Let's see. There you go. There I have it. Here it says a science teacher explored the relationship between the percent of repeated problems in the textbook and the percent of student engagement during a class taught from the same textbook. The science teacher collects information from 6 science textbooks and shows in the table below. Use the graph to plot the points and develop a linear relationship between percent of repeated problems and the percent of student engagement. Keep in mind what they're asking you to plot. They're asking you to plot the percent of repeated problems and the percent of student engagement. So this has to be your X value, this has to be your Y value. All right, so let me scroll down here. And I am starting with book 1. So book 1 is all the way down. My point is 5 and 85. So I'm going to scroll here, 5. Where is it? 5. And move all the way up to 85. Where's my 85? Da 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 da. 81, 82, 83. I'm on 5 and 85 is, it's kind of hard to get it here. Let me expand this one. Let me pause. So what I did here was I used my coordinate points 5 and 85. As you can see, my book 1 is 5 and 85. Book 2 is 15 and 70. As you can see, book 2 is 15 and 70. Book 3 is 20 and 52. So I move my points 20 and 52. Book 4 is 27, 41, 27, 41. Book 5 is 50 and 30. And book 6 is 90 and 20. All you have to do is simply move it up and down. Oops, it is 90 and 20. There you go. There I have it. So using these X and Y coordinates, you will simply be moving your values. I'm going to go ahead and click submit. And it says, congratulations, that's the right answer. So let me go ahead and see if I have any other question. Okay, so once this is done, they're asking you a question that is pertaining to the problem or the one that you just graphed. They say use the linear relationship graphed above to estimate the percent of student engagement for 70% of the textbook problem. So they're asking you, go ahead and see what is estimate the percent of student engagement if 70% of the textbook problems were repeated. So let's go back and see here. As we can see, let me see. Student engagement is 70%. So they're asking you if the student, if you are, let me see. I forgot what they asked. Estimate the percent of student engagement if 70% of the textbook problems were used. So they said if your X is 70, go ahead and calculate what percentage of student engagement would be there. So what you have to do is simply plug in your 70. So they're asking me if the X value is 70, what is the Y value? So if I scroll this further, let me expand this one. Let me see if I can expand this. Yeah, there you go. If I expand this further, which I just did, if the X value is 70, what is the respective Y value? As you can see, the respective Y value is between 20 and 30, which is 25. So they're saying you, hey, when the X value is 70, what is your respective Y value? So I simply start with 70, go all the way up to the line and see what is that respective Y value, which is 25%. All right, so you simply have to move these points based on the X and Y values here. So as you can see, my X value is 5, my Y value is 85. So all I have to do is use this cursor here and move my X and Y values. All right, so let's go ahead and take a look at the next problem. All right. So the next one is to find, let's see, where do I have it? The next one is to find the linear regression equation with the list of data points. So what they're doing is they're just giving you a scattered points or the scattered plot, and they're asking you to find the equation of the line, which is going backward. In the previous cases, they did give us the equation of line and they ask us to get the different x and y values. So to do that, the first thing you have to know is when given a scattered plot, as you know, the word itself describes that the points are all scattered. You will have to find the best line of fit. The best line of fit is the equation that kind of mimics and gives you the perfect relationship between your x and y values. And again, you're always looking for a linear relationship or linear regression. That is the process of fitting the best line of fit in your scattered points. Again, you have to know what is your independent variable, what is your dependent variable, and we will be looking into detailed about sum of squared errors, that is denoted by SSE, and also the estimated value, the regression. So we will be going over each and every of this topic or the verbiage with an example. All right, so what we're going to do is we're going to go jump into the problem so I can explain each and everything. Here you have the following data represents the inches of rainfall Y in the month X of the following year in the city. And it says Jan 1st, 2nd is February. Enter your answers in the form Y is equal to mx plus b. So what they gave us here is they gave us x and y values. And they're asking us to say, hey, we know this is a linear relationship. We want you to go ahead and find y is equal to mx plus b. In order to do that, you first have to go ahead, open up your class calc. The instructions are given below. You go to your class calc, graphing, stats, advanced, and linear regression. Let's go ahead and do that. So here I am in my class calc. Let me go ahead and expand it. I am in my graphing calculator. So when you click here, you're in the graphing. Majority of your stats only works in the graphing calculator because those functionalities will be available in your stats part. Let me go ahead and minimize this one here and let me expand this. There you go. So you start with your graphing calculator. You go to your stats. Oops, I have to be in this window. Stats. And you go to advanced, and then you pick your linear regression. Again, you are looking at linear regression only, so you go ahead and pick your linear regression. And as soon as you pick that, you will have this particular window popped up on this side. There you go. And it's going to ask you for linear regression. So that means the first one has to be your x values and the second one has to be your y values. So let me go ahead and plug in. So here my x values are 1, 2, 3, 4, 5, 6. That's pretty easy to plug in. So let me go ahead and do that. 1, comma 2. Oh, never mind. I have to be in this window. So it's 1, comma 2, comma 3, comma 4, comma 5, comma 6. And then I'm going to go ahead and plug in my y values. That might take some time. I'm going to use my iPad here. My y values are 3.53, oops, wrong number. 3.53, comma 4.93, comma 1.58, comma 2.72, comma 4.68, comma 3.34. There you go. So I went ahead and plugged in my x and y values. Please make sure you are checking and cross-checking those values one more time. As soon as you do that, you will have your, let me expand this. As soon as you do that, you will have your equation right here. As you can see, you have your equation y is equal to negative 0.16x plus 3.519. Let me go ahead and write this down. I'm going to go ahead and copy this and we'll talk more about what this actually means. So my y value is negative 0.16. Did I put in the right one? Yeah. And my y intercept is 5.19. I'm going to keep it to 3 decimal places. Now let's go ahead and take a look at how the graph is and what exactly does it mean. All right, so I'm here. So let me minimize this one. As you can see, this is my scattered plot. The purple line that you see, that is the line of best fit. So what exactly is this line doing? This line will help us predict the values of y given values of x in a particular domain. We're going to talk about this in the next chapter. How do we predict values? But why do we need that? If you look at this, my x values, let me go ahead and close this here. My x values are 1, 2, 3, 4, 5, 6, right? So I have every value for x. What if I want to find out what is my y value when x is 2.2 or 3.2 or 4.2, right? So I can use this equation to predict the values of y. Now let me go back here. In your textbook or in your notes, there is a different formula to calculate your y is equal to mx plus b, but I highly want you all to use your class calc. You go to your stats, advanced, linear regression, plug in your x values, plug in your y values, and there you have it. So these, the red dots are the observed values. Let me zoom in. So the red dots here are the observed values, and the the line here is the line of best fit. So to get the line of best fit, what we do is we find the residual value. The residual value is the difference between your observed and your predicted value. So this is my observed value, and the predicted value is the respective value on that particular line. So we have to take the difference between these two, square it, and find the slope. So you don't have to do all the math. You can simply plug it in your class calc, and here you have your best line of fit. Again, keep in mind the best line of fit is the line that gives you the best relationship between these scattered plots. Points, sorry. As you can see, I have the points scattered everywhere. Just by looking at it, you can see that it is kind of inclining down. So you know that the slope is going to be negative. Let's take a look at the slope here. Where is it? So as you can see, the slope is negative, right? I have my slope is negative, y is equal to mx plus b. My m value is negative. Yes, that is correct, because look at my scattered points. The points are all going down, right? So my slope is negative, and my y-intercept is right here. That is my y-intercept, which is right here, which is 3.51, as you can see. So this class cal gives you a total idea of what a scattered plot is, what is the best line of fit, and as if you look further here, let me reduce this a little bit and bring it to this side. There you go. If you can see, all these x and y values have been plugged in right here. So this is the entire scattered plot, and class cal gives you the line y is equal to mx plus b, which gives you the best relationship between these scattered plots. And based on the best line of fit, you can use this equation to predict your y values within the respected domain of x. We're going to be talking about that later, but this is how you calculate your y is equal to mx plus b, and here you have your slope negative 0.016 and your y-intercept is 3.519. You simply go ahead, copy this down as it is. All right, let's go ahead and take a look at the next problem. So what I'm going to do is I'm going to go ahead and delete this one, because we're going to be doing everything. Oh, I have to delete here. Okay, so let's go ahead and take a look at the next problem. Gabrielle and Raj were running a lemonade stand at the local park. They decided to pay their sister to operate the stand. The following values represent the profit, Y, after X hours of standing. of the stand being open. Enter your answers in the form y is equal to mx plus b. Again, this is a scattered plot, so you have x values at x is 1, 2, 3, 4, 5, 6, 7, and your y values are whatever values that you see, right? So what you're going to do is you're going to go ahead, go to your class calc, graphing calculator, stats, advanced, linear, and plug in these values. And let's go ahead and see how the plot looks first. So class calc, let me go ahead, expand it, cover my face up. That's okay. All right, so I'm going to go to class calc, stats, advanced, and linear regression. And as soon as I do that, this is where the linear regression comes in, right? I'm going to go ahead and plug in my x and y values. I'm going to go ahead and plug in my x is where it's right here. My x value is 1, comma 2, comma 3, comma 4, comma 5, and comma 6. I think I have a seventh one too. Let me check. Yeah, I have a seventh one. I'm going to go ahead and plug in my y values, which are 3.58, comma 5.18, comma 6.24, comma 7.97, comma 7.09, comma 8.31, comma 11.33. There you go. As soon as I do that, I want to go ahead and show you how the graph looks. So this is my scattered plot. Oops, I think I'm maximizing it. Let me minimize this. You see how my graph looks? This is my graph. This is my scattered plot. Just by looking at the graph, I know my graph is going up. My slope is positive, and I also have my y-intercept right here. So if I zoom into it, as you can see, the red line is the line of best fit. That is pretty much close to every point right there, which is calculated with the huge complicated formula which you don't have to know. But the red dots that you see, those are the observed values. And the respective dots on the particular line are predicted values. You take the difference between these two to find the equation of the line, which you don't have to know because class calc does it for us. Just by looking at the scattered plot, you know the scattered plot is going up, so my slope is positive. That means as x value increases, the y value also increases. All right. Okay, so now once we have this, let's go ahead and look at the equation here. What is the equation? The one right here, 1.08 x plus 2.762, right? So I'm going to go ahead and use this equation to go ahead and write it down. As you can see, my y value, y is equal to mx plus b form. My m is, let me expand this. My m is 1.084. I'm going to keep it to 3 decimal places. And my y value is 2.763. Fair enough? So this is your slope and this is your y-intercept. Sometimes they ask you just for slope or just for y-intercept. If they ask you for slope, you know what your slope is, m, which is 1.084. If they ask you for your y-intercept, which is your b, which is 2.763. And that pretty much covers the topic for today. Oops, I should have closed this one. So your slope is just your 1.084 and your y-intercept is 2.763. Sometimes they ask you for slope and y-intercept. Sometimes they ask you just for slope. But it doesn't matter what they ask you. So you simply use your class calc to find your equation y is equal to mx plus b. Again, class calc, graphing, stats, advanced, and linear regression. I hope this video helps. Again, if you have any questions, you can comment below or email me or text me. Good luck.